Hello and welcome. Today we're going to be looking at measures of a spread. This is different than the mean, median, and mode that we looked at in the previous lesson, where we were looking at ways to measure the center of our data. With variance and standard deviation, we'll be looking at ways to determine how close together or how far apart our values are in our data set. So when we're talking about deviation, we're looking at how far an element is from the mean of the data set. So when we're looking for a standard deviation, we're looking for some sort of average of the deviations of each element. So we'll start by going through the process of calculating a standard deviation using the set that we see on the screen. Just know that typically we don't do this by hand step by step, and instead we will look at how to do this with the calculator or with Desmos, but it's important to see the calculation at least once so you have an idea of where those numbers are coming from. Our first step in finding the standard deviation is to find the mean of the data set, which once again means that we're going to add all of the terms in the set and then divide by the number of terms. So we can go ahead and add these values right here and then divide by 6, which will give us 22.5. Next, we're going to find the deviations by subtracting each of our data points by the mean. So if I subtract 10 and 22.5, I get negative 12.5. 15 minus 22.5 to get negative 7.5, so on and so forth. If we try to average our deviations together, the total is always going to come out to 0, because if we notice, the negative numbers match the positive numbers, so when we try to add everything up, it's all just going to cancel out. Instead, what we're going to do is square all of our deviations to get rid of all those negative numbers. So if we do negative 12.5 times negative 12.5, it gives me 156.25. If I do negative 7.5 times negative 7.5, it gives me 56.25. Again, so on and so forth. So now if I go to average these numbers together, I will get an actual non-zero value. So if I add up all of my deviation squareds and then divide by 6, that gives me 72.917 rounded to 3 decimal places. That average is what we call the variance of our data set. So obviously the problem here is that in order to get that number, we had to square all of the values in our deviation column, which means that the units of our variance don't match the units that we started with. So to get the standard deviation, we're just going to take the 72.917 and then take the square root, so it shrinks it back down to be something closer to the numbers that we started with. So to find the standard deviation, we take the square root of the variance. The square root of 72.917 is about 8.539. Therefore, the standard deviation of our data is 8.539. So once again, to find the standard deviation of a set of data, you start by calculating the mean. You then subtract the mean from each value in the data set to get the deviations. You square those numbers to get rid of the negatives. You take the average of the deviations squared to get the variance, and then you square root it back so that your standard deviation has the same units as whatever numbers you started with. So for our purposes, we're not going to be doing that by hand very often. More often than not, we're going to use either the calculator or Desmos to get the variance and standard deviation from a set of data. The commands are VARP for variance and STDEVP for standard deviation. The P stands for population, which tells your calculator that the data set is complete, as opposed to numbers taken from a larger set of data, because taking the numbers from a larger set of data would change the formula for calculating standard deviation slightly. So if I was doing this on Desmos, I would just make a table and put all of my data into a column, and then use my commands for variance and standard deviation to just get the values. All right, next quick thing that we need to know is that we can use function notation to represent data that is written in a frequency table. You can think of this just like your X column and your Y column. So if I'm asked to find f of 14, this is basically saying what is the frequency of 14. So as I go to answer these, f of 14 equals 4 because 4 students had an age of 14 years. f16 equals 3 because the age 16 appeared 3 times in my list. However, if I try to find f of 3, I don't have 3 in my X column, so that last one is undefined. If my frequency distribution is given as a histogram, I need to remember that each bar represents a range of values, and the number on the left side of the bar represents the beginning of that bar. So using this histogram as an example, the first bar represents the values between 12 and 14, starting with 12. So f of 12 and f of 14 are both 4. However, f of 16 would be 8 because the 16 represents the start of this bar right here. And that's all we have for this one. I'll see you guys next time.